Okay, so in this video, we will be going over how to do the pretty much review for the test. Test Unit 3, I believe it is. So our first question, it is pretty much a spring force question because we see the spring here. And there are two mechanisms set up, and they both have the they're both connected because it's the same spring. And we are asked to find the change in x, the delta x here. So first, let's set up an equation for this too, so that we can, or actually what we can do here is we can start here, the right side to solve, because spring force equals negative kx, right? In this case, this is y. So our Fs, well, we know it's mg, so 22.0 times 9.81 equals, and then that's the Fs, negative k. Negative k x. What is x? Well, it's final minus initial. So the final is down here, so it's negative 0.61. So, and remember here, he said the negative k, it doesn't really matter that much. So let's just solve for k here. Pretty much simple algebra, 22 times 9.81 divided by 0.61. And our k comes out to 354. And the units for k are Newton per meters. So our spring force there, that's pretty much what we solved for, and we solved for the k. So now with this k, it's the same exact case, and it's the same exact spring. So we can try and use it in this mechanism here to find the delta x. So what can we do? Well, let's think about this. Let's put all our forces together. So this is going down this way, and the acceleration is 0 since it's still, it really hasn't gone anywhere. So what we can do is we can set up our spring force. So we know spring force equals negative kx. So our k, we can do 354 times delta x equals the forces pretty much here, the other spring force. So what is this? How do we do this? Well, it's mg sine theta, right? We know all those, so we can do 22.0 times 9.81 times sine 52.0, right? And then what else is acting against this force? Well, it's friction. And how do we solve for friction? Well, we know force of friction equals normal force times mu. And we have all those because we can solve for normal force here. So I don't want to overlap, so we'll just come here. So it's minus friction, which is normal force. What is normal force? mg cos theta, right? So 22.0 times 9.81 cosine 52.0. And we can do numeric solver, and our delta x, let's see, we can go 354, x equals 22 times 9.81 sine 52 minus 22 times 9.81 cosine 52. And we should get our delta x comes out to 0.441 meters. Might have been a little calculator, but yeah. So that is our delta x, and that is how to do a spring force problem like that. Okay, our next question involves a beloved friend of ours, Ani Rue. So in this problem, Ani is being pulled kind of at this vector here at 57.5 newtons, and the theta, well, our question asked to find the acceleration at these two given thetas. So theta equals 0, so it'll be like this, and theta equals 30, like that. So Ani weighs 22.0 kilograms, which is actually pretty skinny. Good for you, Ani. And this is our friction that is given. So let's set up one for theta equals 0. Theta equals 0. Well, we know net force, right? Net force equals ma. So what is ma? Well, we have to solve for a, but we do know m because Ani is 22.0 times a, right? That's what we're solving for, equals, so we have to find pretty much what this force is. So he's being pulled in the horizontal direction, so we have to see what that is. Well, how do we do that? Well, we can increase our triangle here, so it looks like this, right? This is our 0 degrees. It looks weird, but let's just envision it. And this is our opposite. This is our adjacent. So we have to go in the horizontal direction, so we're going to do cosine, right? Because cosine deals with adjacent. So it's going to be r cos theta. So r is 57.5 cosine 0 minus the friction. What is friction? Well, we set it up here. Friction is normal force times mu. Well, what is the normal force here? Well, it's perpendicular to the surface, right? Which the surface is just going mg, so it's just also going to be mg times the coefficient of friction, 231 times mg, which is 22.0 times 9.81. So we can solve for a here, and pretty much the cosine 0 is just 1, right? So it's just it's not really necessary, but you know, it can't hurt to add it just so you can understand it more, if that makes sense. And our acceleration comes out to be, just do numeric solver, 0.348 meters per second squared. Now let's do 30 degrees. Theta equals 30 degrees. So once again, we can set up our MA. What is M? 22.0 times A. That's what we're solving for. And we can set up the equation. So this one's kind of a little funky, but we can do it. So again, it's r cos theta because it's dealing with adjacent. So 57.5 cosine, but this time it's 30 degrees. So this is what our triangle looks like, right? And it's going like that. And cosine 30. Now we have to minus it. Well, let's think about this. We're doing friction here. However, we have to take into account how this is being lifted up above, Ani is being lifted up above the ground, so that means our normal force is going to decrease. And so that means we have to subtract it by how much it is being lifted in the y direction. So we can do minus our friction coefficient, right? 0.231, and then times. So what is our normal force? Well, our normal force is 22 times 9.81. However, like I said, it has to be minused by however much it's being lifted in the y direction. So here we have to use sine to find our y direction here. So minus r sine theta, 57.5 sine 30 degrees. And we can solve numeric solver for a here. And that comes out to 0.299 meters per second squared. So that is how you do those two questions. Okay, our next question is actually pretty much the quiz question, but a little twist to it. So here we have Kevin hanging from these two ropes here, and there is 3 tensions that are formed here, and we have to find all of these tensions. So how can we go about this? So we know that we cannot use trig functions on obtuse angles, right guys? We know that. So we have to make this into a right triangle. So let's enlarge this. So this is what it looks like, right? And this is 127.3. So the most simple triangle here would be this right here. And this would be our theta. And how do we solve that? Well, simple. Geometry 180 minus 127.3. This theta is 52.7. That's bad. 52.7 degrees. So once we have that, we can set up an this is our hypotenuse, this is the opposite, and this is the adjacent here. Sorry about that. This is the adjacent side. So now we have that set up. So let's just put that to the side for now. So then we can find T3 really simply here. What is it? Well, it's just mg, right? So 23 equals m 22.1 times 9.81. And that comes out to T3 22.1 times 9.81 equals 217 newtons. So that is our T3. Yay. So now we can separate these into X and Y. Now, in the for the Y, we can do T3 equals, so 217 newtons equals T1Y plus T2Y. So, once we have this, we can set up our X direction, which is T1X equals T2X. So, what do we do from here? Well, T1, okay, so this is T1, right? We have our new triangle here, and we have to find the X direction of it. So we're actually going to have to use a sine function here, because the X direction, sorry, that's my ice machine. The X direction is opposite. So what sine uses opposite over hypotenuse, right? So we need to use sine here. So T1 sine theta, what's the theta? New theta, 52.7 equals T2, and this is the regular cosine, right? Because this is normal theta, which is 62.6. Now, let's isolate. T1 equals T2 cosine 62.6 over sine 52.7. Now, let's substitute. So this is 217, sorry. 217 equals T1, and the y direction here is actually adjacent, so we use cosine. T1 cosine theta, which is 52.7, plus T2 sine, this is regular, 62.6. Now plug in chug. 217 equals, well, T1, well, we solved for it. It's T2 cos 62.6 over sine 52.7 times cosine 52.7 plus T2 sine 62.6. So now we only have one variable, and we can solve for T2 here. So 217, just do numeric solver. X cos 62.6, make sure you're in degrees, sine 52.7 times cosine 52.7 plus x times sine 62.6. And our T2 comes out to 175 newtons. T2 equals 175 newtons, right? So we have T2 and T3, and now we just have to solve for T1. Well, what can we do to solve for T1? Well, just plug it back into this. So T1 equals 175 cosine 62.6 over sine 62.6, or 52.7. Oh, sorry, 52.7. So let's just plug that in. 175 cosine 62.6 over sine 52.7. And we get our T1 equals 101 newtons. That is how to solve for all those three tensions. Okay, our next question is asking, will this box move? So we are given that the acceleration equals 0. The force applied on it is 21 newtons and the 30 degrees from horizontal. And the mass is 10 and friction is 0.310. So how do we do this? Well, first let's find the force in the x and y direction. So Fx equals, oh, this is our adjacent side, and finishing this triangle, this is our opposite side. So x is finding adjacent, which deals with cosine. So Fx equals 21.0, because our cos theta, cosine 30, this comes out to 21 cosine 30, comes out to 18.2 newtons. And then our Fy, same thing with sine. So 21.0 sine 30, right? Because sine is dealing with the opposite, which is y direction. So this comes out to 21 sine 30, 10.5 newtons. So that is how we figure out our forces in the x and y direction, right? And now friction is acting against this force. Well, how do we find friction here? Well, we have to find our normal force, but then we are given, because remember, friction equals normal force times mu. So how do we solve for normal force? Well, Fn equals mg, right, 10.0 times 9.81, since it's perpendicular to the surface. However, it is this minus, right, our Fy, right, because it is being lifted up the ground. So that means the normal force is less. So it's subtracted by this Fy. What is the Fy? 10.5. So 10 times 9.81 minus 10.5. So our normal force equals 87.6. So close, flip those around, 6, 7. And then, how do we find friction? Well, times that by mu. So friction equals 87.6 times mu, 0.310. So friction equals times 0.310. Friction equals 27.2 newtons. So now if we're wanting to know if this will move, well, let's check if the friction is larger or smaller than our Fx. So our Fx is 18.2 newtons, and our friction is 27.2 newtons. So which one is greater? Well, 27.2. So that would mean the friction would overcome this force, and thus this would not move. So that is how to answer that question.